Hi, thanks so much for the introduction. As you said, I work at Guide at Georgetown and with the Dime Analytics group in the World Bank. Let me just get the screen shared here. So how many people do we have today? We have a good group. So has everyone, before I start, has everyone shared their username with me in the Slack channel so that I can add you to the repository? Oh, and I teach a very interactive class, so please feel free to unmute and just chat with me because this is, as I said, a course, a session based around collaboration. And so we'll really be wanting to go back and forth and work as if we're on the same team working on a project today. The pad carpentry is not this session. So if you're trying to go in the other session, that's okay. Let me get one more in. I'm going to add Carlos. Good. All right. If anybody else needs anything, just ask. So let me see if I can share my screen. There it is. Okay, you can all see the presentation. If no one says yes, I'm going to assume the answer is no.
It hasn't started yet, at least on my
it hasn't
end.
started yet.
So maybe we'll just give it a few seconds to load. Yep, now I see it.
You got it. Okay, great. And if I move it away, did you still see it? No, it didn't need to be actively on the screen. I'm sorry, everyone obviously works differently, so I just need to know that I need to leave that monitor on there, and that I will do.
Yep,
Wonderful.
I can see it.
Great. So, right, Benjamin Daniels from Georgetown University and Dime Analytics. I'm sure you all have seen this slide many times now throughout the course of the last couple of days and sessions. And as we said, today we're going to work on a very move away from the high level elements and look at a very specific technical application of one element of collaboration and reproducibility. And that, as you all know, is Git and GitHub. In this session, we're going to use GitKraken, which we sent instructions to install and set up. So everyone should have that as well as their GitHub accounts ready. What we're going to do is work through a very simple approach to a collaborative workflow in Git using GitHub and GitKraken as our kind of interfaces. And everyone will be able to participate in that. So does anyone have comments or feedback or anything that they wanted to ask before we get started about the technical requirements, about the introductory videos or the pre-exercise or anything that came up over the past couple of days working on this stuff? Does anyone have any thoughts at all? Great. Okay, so I'm going to ask you to follow along here as I just do a quick review of the concepts from those videos. And then about 20 or 30 minutes in, we're going to move to the live demo. So everyone, if you have a moment, make sure you have GitKraken open and have an internet browser on github.com. And we will do that, work through that together after the concepts review. So this is the most fundamental place to start is what are these things? How many people here feel that they're reasonably familiar with Git and GitHub, and how many just say, briefly, do you have a lot of experience or are you relatively new from a couple people in the group? I'll call on people if people aren't connected. How about Juan? I see a video there.
Sure, I have some experience with GitHub because I took a computational tools and techniques course within my department, but I guess now we have to learn about GitKraken, so let's get cracking.
Great. Yes, and that's very good. Does someone this for once? I think is the first time I don't have to explain the joke in this session. So thank you for that one, Juan. So let me start where a lot of people get confused, and I think that bringing up the software that we're going to use is a good place to do it. So Git and GitHub are usually the terms people hear first when they get introduced to these technologies. Git is not GitHub. GitHub is not Git. GitKraken is neither of these things. Git is a version control software, right? It organizes versions of the files in your project in an orderly way. No matter what interface you're using, whether you're using GitHub, GitKraken, GitHub Desktop, or the command line, you are using Git, right? So all of these things are interoperable because they use an underlying technology to communicate with each other. So the way I typically try to introduce this to the group conceptually is that it's a lot like email, meaning that no matter what kind of email you have, you can communicate with other people who are using email. So Git is like that. There's an underlying standard and an underlying set of processes that are happening no matter how you interact with it. And whether you go online through gmail.com or I forget the office one, with the outlook.com to access your email inbox, whether you access that through a dedicated application on your desktop computer, like the mail app, or whether you do it on your phone, you're accessing the same information using the same protocol with different interfaces, basically allowing you to do that. And why do we use these interfaces? Because they're convenient, because they can organize information to you in a more intelligible way, right? You could theoretically go into the command line and have it feed you out the raw underlying information of your emails. If you were really, really crazy, you might actually even be able to read them that way. The information is there. It will be able to tell you who sent it to you, when they sent it, and the contents of the email, and any signatures and other information such as attachments to the email. But nobody reads their email like that because it's a real pain in the neck. So we use these other tools such as GitKraken, GitHub Desktop, and GitHub to make this stuff manageable. Now, I want to turn immediately to GitHub because it's a special case here. It's not GitHub is not running on your computer, right? It's not a program that you interact with on your desktop in the regular workflow, right? It's a development platform that we use online to manage contributions. So we think of GitHub similar to what we think of as an email server. It collects messages from different people coming from their applications on their desktop that are sent using the same protocol, and make sure that they're actually sent to each other and communicated in an orderly way, which can then come back down to your email thing, and you can then respond to. So this is how we think of these kind of components, right? Git is the underlying architecture. GitHub is a development platform that manages connections and contributions. And then whatever's running on your desktop, no matter what type of thing you're running, will all be interoperable using those two things. And there are replacements for GitHub. There's GitLab, there's Bitbucket, there's other services that provide a similar thing, but everyone does, of course, need to be connected on the same platform to work on a project together. So why do we do all this? Why do we spend the time learning this relatively new software, which does something that we haven't really done in the past? Well, it solves this problem, which we call the final.doc problem. And that is, as you move through the process of creating outputs, you inevitably have different versions. There's only space for one, right? You only need one of these versions to be the kind of active version, but you typically want to keep a record of everything you did in the past so that you can go back and access it, edit it, change it, update it. The way that it's done kind of naively is the version shown here, that the file itself is renamed, relabeled, edited to show how, when, why, and who are making changes to the components. That's okay, in a conceptual sense, if you're just going back and forth. That is actually the information we want to record: how, when, why, and who. But we don't actually want to do that in the name of the files, especially if you're filling up your computer with multiple copies. If you're changing names of things that you actually need to have code references to, these will break your code references. So we want to come up with a way of making it such that our file names never change and that we actually only are able to view the versions of files that are relevant to us right now. Another way of putting that is that we want to Marie Kondo our folders, that we only want to see the things that give us joy now. And we can always go back and get the other things, which is why we use a specialized software to do this. But when you open a Git folder which is tidied in this way, you'll only see the project that you want to see and that you want to be working on. So it's a long introduction. We're going to get to some of the details right now. And hopefully this will become clear as we go through. So as you said, Git is a software that runs on your computer. It stores histories of your files in a way that is really, really useful, but that you do not need to understand in any sort of technical way. So don't worry about it. Again, I'm going to show you the human version of this stuff rather than the technical version of this stuff. A little bit of terminology that we have to get started with. The complete history of a project is called a repository. Very quickly, we'll start having some vocabulary clash where people, and you'll often hear the actual contents of the files referred to as the repository. I'll start doing that within a couple of slides. But in the strictly technical sense, the repository is the complete history of the project. You can view the contents of a repository in a client such as GitKraken, which is shown here and which we'll use for the demo. A very simple repository looks like this one. It has a series of versions called commits that make up the history, that make up the repository. Now, each commit is a record of the changes between itself and the previous commit, and these are taken at the level of the entire repository. So these are not file level changes. These are folder or immediately I'm going to start saying repository changes, but what we mean is something like directory level changes. So it's a snapshot of the entire project at a given point in time. GitHub is a website that you can use to manage collaboration with other people. It has two main kind of forms of interacting and functionalities. One is it's an excellent task manager. So this issues approach, as you'll see, most of the stuff on this website is not related to Git at all, but is actually project management that is connected with Git. And the second feature of GitHub is that it actually allows some Git functionalities, such as merging things from different contributors, to be done in a specially designed environment for that kind of collaboration. So a simple issue and a simple merge looks like this one. A problem is posed in plain language by someone who wants to have something done on the project, and someone, here me, proposes an implementation, posts a version of the version of the project in which the problem is solved, and the team can decide whether to incorporate that solution to the problem to the product, to the current version of the project. So Git and GitHub work together. They're designed to work together. GitHub is built on top of Git. And mastering that gives you the tool for managing your team's workflow, as well as making and releasing big projects on your own or with any number of people. As you heard in the last, the previous session, having this data, code, and code history available, at least within your team, and to some extent, potentially publicly, makes a useful product of the work in addition to the work itself. So it's all about, including this broader set of what we think of as research outputs in the research workflow and making it easy for you to do that. In addition, Git is a very, very, very good backup system. Typical file syncing systems such as OneDrive and Dropbox are okay, but tend to have, they're not really designed as backup services. So we don't treat them that way. Git is designed as a backup service. You have histories available both on the remote server, which would be GitHub itself, as well as on all of the participants' machines. So it's a distributed backup service where there's always easy to recover previous materials. So again, I reiterate, the files are not the repository, even though me and you and everyone else in the world is going to call them that. Your Git repositories are the histories of these projects. What we're going to try to be, as much as we can, is be a little bit explicit about this and calling the place where the files actually live the working directory, the project folder, the directory, or something like that. Again, we're going to be calling it the repository very quickly, but let's separate those ideas for now. The repository is the history of these things that live in the working directory or the project folder. Any questions about those terminologies or these things before we start looking forward? Anyway, go ahead and put anything in chat if you have something. What is the repository? How is Git actually working? You really don't need to know, but I will show you. The Git repository is a bunch of files that are hidden inside the working directory. If you know how to look at hidden files, don't do it. If you don't know how to look at files, also don't do it. Don't touch this stuff. It is not meant to be manually interacted with. But as you can see, it is a coded history of all of the versions of this project, written in a way that the Git script can interact with and recall very quickly. Just pretend it doesn't exist. Everything relevant is going to be displayed to you visually and intuitively through your Git client. And that's what we're going to do for fun and profit. So how does it work? Let's review the two elements of Git here, the two objects, commits and branches. So Git creates commits. The commit is the real material of the project history. It's the real material of the repository. It is the only thing that can be in a Git repository. In GitKraken, it's represented by these little dots. So that's what we call a commit. It is a snapshot of the entire working directory, and it has a name, a timestamp, and an author. So again, the three things that we typically try to record when we're doing the file naming thing, who, when, and why, are stored automatically by Git along with the picture of the working directory as it was when the commit was made. So in some sense, this is literally all that Git does. You tell it when to make this kind of object, a commit, to take a snapshot of your project, and it does. It doesn't do anything else in some sense. The biggest difference from this approach to whatever you're doing now is that it is an entirely manual process. You have to determine when you want these things to be made. And what these commits do is name past versions of your project. So in a sense, you can already see here the approach, the backup approach and functionality that we're talking about, right? You always will be able to, and I'll show you how later. Like, can you see my mouse on here? Yes, no, maybe?
Yep, we can see your mouse.
Great. So you can see here that you're already getting a chronological history of the versions of your project that you named. And I will show you, it is very easy to access these, to be able to recover old materials, to see how you tried something in the past, you know, all the reasons why you would want to have access to a previous version of your material. So those are all available right here. From the very first time you start pressing commit, you get this chronological backup / history. And that's the basic set of what a repository is. You name them, which is the why, right? You get this little ability to title them. You see who's done it, and you see when they've done it. Have some reading here on Git versus Dropbox in terms of the storage and backup feature. And that is a good place to start. Now, the second thing that Git does is new, right? That the chronological backups make kind of intuitive sense to everyone, right? You know, everyone here has a sense of, okay, things change over time and we can kind of build a mental model of that, right? The thing that Git does, which is typically not something you already have a mental model for, is creating branches. Branches are everywhere called the killer feature of Git. This is what distinguishes it from any other software you may be using to collaborate or back up your work. Every advanced Git and every practical usage of Git will require you to manage and understand what branches are and how they work. One thing to immediately stop thinking of if your brain is already going in that direction, and it usually does, a branch is not a folder for commits. Don't stop that right now. And as next time your brain tells you, oh, I have all my commits in a branch, say, no, that's not how it works. Branches are something different. They are access points to commits, and I'll explain that more in a bit. And what they do is enable different people to work on the same thing at the same time, or for you to switch between things at the same time. And they let you view those different versions of their files. Again, they let you access commits. They don't actually contain anything themselves. They certainly don't contain commits. branching lets you move forward or backwards in time, which is an intuitive functionality from the chronological model that we had before. But once you have branches in your work process, they also let you move horizontally in time, right, through various concurrent versions or alternate versions of your project. And that's what you're gonna really want to do when it comes to talking about collaboration. So the key feature of branches in this perspective is that branches give names to current versions. And these versions exist simultaneously in the repository. That is a branching history. It is a back to the future, multiple timelines kind of thing, and we're going to learn to work with that. So you can switch between branches locally. What this will do is make your working directory appear exactly as it did when that commit was made. So that's how we move forward and backward through time, is creating branches that give us access to historical commits. And it's also how we move horizontally through time, which is by creating and maintaining branches that give us access to simultaneous commits that may be happening around the same time, but doing different things. So every contributor can change at any time without affecting the rest of the project. So you can see immediately, as opposed to something like a sync feature like Dropbox or OneDrive that requires people to have the same material at the same time. Git allows you to work asynchronously. And anybody can get to any version at any time without affecting the others. So this means you can make experimental changes or review the history yourself without bothering anyone else, and in a very easy to do way. I haven't mentioned this explicitly here, but one thing that's really important about Git is that it is fast. It is very, very efficient in letting you do these things, and is very efficient in storing all these versions for certain types of files. So how is it better than Dropbox? Who's been here? Let me just see some hands. It gets a little bit of something in here. So who's seen this window in their lifetime? If you haven't, I don't believe that you have a job. And we all know why this is a nightmare, right? Because it has some of the things that we want in an organized history, right? It has an author. It has a timestamp, but Dropbox never asks you why you did something, and it doesn't give you any way to record why you did something, and it doesn't make these snapshots in an organized fashion, in the sense that it just makes a snapshot every time you press save. It doesn't wait for you to say, I've done something like that has a human meaning. The other thing it doesn't do is that it doesn't preserve concordance for the project, right? It's storing snapshots at the file level. So you know you can go to Dropbox this site and find, okay, even if you can go through find, oh, this is the one that I want, it doesn't, there's no way to say, okay, show me the way that all of my other files were at the time that this snapshot was made. So if anything else has changed, if you've changed names, references, folder structures, literally anything, just getting the old version of a particular piece of code back may not make the project work. So again, Git is doing this in a particular way where the snapshots are taken at the working directory or project level. So whenever you go into the past, everything will work together just as it did then. And that's what we want for these code products, where there's lots of dependencies between files and structures. Similarly, anyone who's ever gone into Dropbox and seen this knows that they have just lost their entire day to very, very boring and tedious work. And sometimes there is no good way to do this. So this is people doing things simultaneously to the same files. This is what we are able to do in Git using branches. And again, it is the reason that we're going to do this. You can do different things to the same file at the same time. And ultimately, you can move forward in a way that preserves everyone's work without having to be manually reconciled. Similarly, in Dropbox, if you're going back in time, if you're rolling back a file, everyone else also gets forced to do that as well, even if they weren't expecting it. So it is not easy to collaborate on these kind of things through Dropbox because of the way it's built, unless you have such a workflow of really keeping an eye on everyone's time, what they have open, what they forgot they have open, all of these things. and everyone's able to check other people's changes very quickly. So it's not very conducive to working like that, and Git is. Now, I'm not saying this is easy. This is a totally new set of skills, a totally new mental model of how your computer is working and how it's organizing information. It's a new type of information, and that new type of information needs a new structure. So part of the work that we're going to do today is build a mental model of what this information is and how it can be stored and used. So again, this is not easy. Git was not designed to do this. It took more than 5 years from the initial release of Git for someone to sit down and say, okay, this is how we're actually going to use it. So this is not a purpose-built or like intended work, but it is a workflow. It is a mental thing that exists only inside our heads, not in the technology. So that's why we have to teach it. And it's not written, it is written down lots of places, but it is a human invention and it is a human concept. And that's what we're here to do. And so we're going to train ourselves to think in these new ways. And the most important part of doing it is that we're going to train ourselves together at the same time to think in the same way so that we know what to expect when we're working with other people. So does that make sense as what the kind of like high level functionalities here and what the goals of today's work are going to be?
Ben, I have a few questions. This is all very interesting. I'm just curious, is there any notion of the cloud? Are we putting like data to the cloud or saving it somewhere on the internet in addition to the computer? And I guess relatedly, what's the situation with storage? I mean, if we're kind of keeping all this historical things, I mean, we do that anyway in our computers. But I was just wondering, is it going to like reduce the computer storage, or is there like unlimited storage if we, put it on the cloud, if there exists one?
So yes, you are, if you're using GitHub, you're using the cloud to store a backup of your information. I tend to do that myself, even if I'm not working with anybody else, to have that backup. They have storage limits. You can see what they are. They let you pay for more, typical kind of, cloud storage service stuff there. It does not save space on your computer in the way that I think you might be suggesting, because the cloud is only a copy here. Your computer will also locally store the entire copy. So you're not offloading information to the GitHub service. However, Git, the underlying software is very efficient in the way that it stores histories. Again, and I'll elaborate now, on certain types of files, right? And that type of file is really plain text files, binary files, code files. You don't use Git to version PDFs because there's no way to reconcile those and store them officially. It will actually bloat very fast if you start storing multiple versions of PDFs, Office documents, and so on, right? Which is why, similarly in our work, we move towards using LaTeX to produce PDFs, so we never have to store the old version of the PDFs. We simply store the raw materials as text files, which can be stored very, very efficiently in the history. So here it's a lot more about keeping historical versions of the exact inputs and processes that will create such a document, but not actually necessarily storing versions of the document itself. Does that make sense?
Yes, thank you very much.
Mm-hmm. I mean, there's limited, as you learn more, you'll kind of learn what works and what doesn't. But that's the kind of loose rules, like, store the recipe, store the code, store the LaTeX, and then don't store the outputs, the images, the documents themselves. And there's ways to instruct Git automatically to do that. It's called Git ignore, and you will say ignore certain file types that don't store efficiently. And we have, Dime, for example, we have a standard Git ignore package that we tell everyone to start with. And if you need something else, then we go ahead and modify that to meet the project's needs. So how does it work? We're going to organize our commits in branches. And this is a thing that is important because we're all going to do it together. So Git flow is the name of the approach that I'm going to introduce here. You don't have to use it, but it is very, very popular. Most projects use Git flow or something very close to it to organize commits and branches. The key is everyone on the team knows the same approach, and it's the same between teams, right? So you slide into a new team or a new project, and everyone already knows, hey, we're going to be using Git flow. So here's how your branches are going to be organized. Here's how your commits are going to be organized. And here's how the merges are going to be organized. So there's a reading here in the slides. Go ahead and do that. And what we'll see is here's what a typical structure might look like. It looks complicated, but it's not that bad. The point of what we're going to do is we're going to break this down to the individual pieces that build up that repository, that history of versions, that history of snapshots of our project. And we're going to do it in this way, with a core structure of 3 types of branches and commits. And we're going to do it this way so that we can correlate them with mental models of human work. So there's what we call a master branch, which is now actually needed to update that. That's now called the main branch canonically. And I will need to actually update that because that was recently finalized and pushed out through GitHub in general. So it would be the main branch going forward is protected, meaning you don't edit it. It's always ready to run, which means it's showing a version of the project that is fully functional. And it has very sparse commits. These correspond to things that your boss's boss, assuming that most of you are about the same level as I am, seniority. I see Bilal is on here. So this is actually, or he was a minute ago. So this is stuff that Bilal would care about. So you see it's those blue dots in the diagram here. It is versions that are ready. In my case, I work on academic materials. So we talk about something like a first draft, a draft for submission to a working paper, a draft for submission to a journal, a revision for a journal, and the final published version might be the only commits on master or main in a project of mine. So these are, like I said, executive level stuff. It's what your boss's boss cares about. It's what goes in your annual reports. It's your deliverables for your grant or subaward, that level of executive kind of completion. Right. And so that's the concept here. The next one we have is a develop branch, which is also protected, meaning you're not doing work on it. It's nearly ready to run in the sense that it's not the finished project because it doesn't have things like your cover page, version, the comments, some of the little bells and whistles that require, whenever you make a proper release. But it works. And it has relatively frequent commits from feature branches. So this is a record of tasks getting done. These are the things your boss cares about. Update table 1, change figure 2, rewrite chapter 3, right? Again, executive, what we think of as tasks, but still in a pretty abstract from what it takes to actually get those tasks done. So a feature branch is where those executive level tasks actually get done and where all the work is going to happen. So where a branch itself might be called rewrite chapter 3, the commits that are made on that feature branch are going to have names and purposes like rewrite paragraph 2, fix typo for there and there, regenerate figure 1, add clustering and standard errors in table 2. The things that you put on your to-do list. And that's what's going to go in here. And the reason they're going to go in here is because your boss doesn't care. Your boss doesn't care how you got to recomplete chapter 2 or update the version, but you do. And you need to be able to compartmentalize, organize, undo, and redo those micro level tasks at a literal code micro task level. That is the tasks that you care about. So however you mentalize those tasks is fine. And we'll see how that works in a second. So the protected branches, like I said, so the benefits and the reason that we do it is that, as we said in the branching approach, all of these moments are always available to everyone. So the boss, the PI, can always open that main branch and see where we are on the project, what's the version that we have ready to go right now. And anybody can create a feature branch and play around without committing it to the development or the main branches. If you leave feature branches open because they don't, you play around with something that doesn't work, you can always leave that open. Just like the diagram from the previous session, there are things that don't go anywhere. There are things that don't go past you fiddling with them, and there are things that don't go past review in your team. you can let it sit there and you can always go back and open up that version and say, oh yeah, this is what happened when we tried X, and that's why it's not in the paper or the brief, right? So that's also available as well. Again, that's an advanced thing in terms of like classifying and managing those. So we'll show you just the main approach right here now. So GitFlow is so successful and so popular, it is the default for most organizations. It's easy. I'm not asking you to do any kind of technical stuff here, no crazy coding. Like I said, this is not a technical thing. This is in our heads. So I'm going to put it there. And we're going to go ahead and do that. That's pretty good. I hit the half hour more or less bang on. So we have an hour for the exercise. And we're going to do it. So can everyone go ahead and pop open GitKraken now? I'm going to adjust my, I'm going to unshare my screen so I can share my desktop with you. Let's see if I can do that. Let's put this one here. Where'd you go? Yes. Okay, so can we see the GitKraken window? Not yes. So you can see my pointer here. Wait, let me just move a few more things around.
Yep, we can see it.
Wonderful. So if you can, if you don't have, I know the presentation is there on the OSF site. So let me just pop that open. You can see if I switch back and forth between the two windows, right?
Yeah, just to know, are you able to, I think we also see like an album cover for Parliament on the side. Are you able to remove that? Okay, great.
Oh yeah, sorry I had good taste, but it's actually relevant. So let me show you how we're gonna do that. I was trying to pick some good tunes for the exercise we're gonna do here. So if you can go ahead and clone the repository that is linked. Let me get the location for you. One nice thing about GitHub is that the URLs are very predictable. So you can see that I've just put it in the chat. The link is github.com/bbdaniels, which is my username, /gitflow demo, which is the name of the repository. And this will always be the case. So it's very easy to do. If you haven't done it already, I do recommend going back and taking a think about your GitHub username so that it's something that is easy for people to remember and associate with you. Your boss will see it, the world will see it. So don't pick something like your AIM username from 1997, but something that is, yeah, kind of like clean and professional, like email might be, since it is visible and needs people to reference it. So if you have that, have we done that? To do that, you go to the GitHub website. You should see something like this. I think they've now changed the button to say code, the green button. You will copy that URL. Don't click either of the buttons below it. So open in desktop will automatically open GitHub desktop if you have it, which is what we're not going to do. And if you click download zip, you will get a copy of the current state of the main branch. I actually think in this one's still called master. I need to update that. You'll get a current copy of the main branch. You will not get the history if you download the zip. So that's only giving you the one snapshot. And what we need to do right here is get that full history. So forward. So you go into GitKraken, you click the repository manager, which is the little folder icon in the upper left-hand corner. It'll pop up this repository management window. Where to clone to. This should be a high-level folder on your computer, like documents or Dropbox. It should not be inside Dropbox or OneDrive. You cannot run a Git repository inside another syncing service. It's a disaster for lots of reasons. Please don't do it. So you'll see my machine in a second. You'll see that's literally next to my Dropbox folder. I just call it GitHub. And it only has my Git stuff in it. You put that URL in there, what ends in .git, which is telling the service where to find the history from the GitHub server. And it should automatically suggest a name for that working directory for that project folder, which is the same as the repository name. So here it would be, it's not my repo, it's Git demo or something. So it's a little different than this one because I stole that screenshot from an old presentation. Don't worry about this today, but now let's get to it. So we're going to check out. So everyone has a screen now similar to what I'm sharing. You can see my GitKraken window here. Good. Any problems with getting this to pop up in GitKraken? Great. So does anyone want to tell me what we're looking at? Or give me a sense of what we think we're looking at. View. Can I make it bigger? I don't know, Avnish, I'm sorry. There must be a toggle setting.
Yeah, no worries, no worries.
No, it might be a system setting for font size. I actually have never tried that, but that's a great question for future presentations. So let me just go through the chat really quickly. So can I elaborate why you can't do it to OneDrive? Yes, you cannot put it in Dropbox or OneDrive because Git is supposed to be working asynchronously. So if you start moving between branches and versions in Git, it's going to push those things onto other people, right, through the sync service. And since they're supposed to be on potentially different branches doing different work, it's going to forcibly overwrite their stuff because it's a sync service. And we actually don't want to do that. So we never put these materials inside a folder that is being continuously synced because they basically crash into each other. If that makes sense? Yep. So let us, so what are we looking at? We're looking at a commit history in 2 branches. Yes. So we have a master branch, which we're going to go ahead and it should be main from now on. So it's fine. I'll fix that after this. And the develop branch, which we use to add a file. So let's see what we have. Now, again, we're going to, depending on how experienced you are and how getting used to it you are, you'll know that this is the repository. This is the repository manager. The repository contains only the commit history for the repository. And when we actually want to see the file contents themselves, right? So the correctly noted that there aren't any files here. We need to go over to the actual file manager. So if you are familiar with the macOS file structure, this is how it looks when I'm browsing it. If you are on a different layout or if you're on a different OS, you'll see it differently, but obviously the concepts are the same. So in my GitHub folder, which is next to my box folder, my downloads folder, right, a very high level folder in my system, I have all of the projects that I'm currently working stuff on. I can click into the Git flow demo project folder, the working directory, and I can see the 2 files that are in this version of the folder, this commit. So this is what it looked like when I have checked out this one, which is called merge branch develop. Now, yeah, go ahead.
I'm kind of having trouble finding that left panel on the left side. I just see like a new tab, but I don't exactly know how to use the GitKraken exact.
What the options panel here?
Yeah, I already cloned it and everything.
There might be there's a pop out here.
No, unless, nope. Unless I have like a different version or something, but
there's a view show left panel option.
It's grayed out. Like it won't let me click it.
That's a new one. So just follow along, see what you can do. You're not going to need the left panel necessarily. It's just an informational panel. You can do stuff through it, but everything that we're going to do, you'll be able to do without it. So I'll focus on doing it in the history window here. So we're going to do a couple things first. We're going to first show you what branches can do and how we can move through time in the chronological sense to get to different commits. So if you go ahead, you can do something like you can click on a commit, like update readme.md, and you'll see that it comes, that GitKraken very nicely illustrates histories for you, right? So you can see that in this version, the main version at commit ABEBCF has in its history update readme.md, and it also has a history to add a second file. So the version that we see right now has readme.md updated, and it has a new file. Let's see a version of this repository. So again, I'm going to start using the repository lingo a little more loosely as we go, because it's really the only way. Let's see a version of this repository that doesn't have the second file. So all we have to do that is find a commit that doesn't have add a second file in its history, such as update readme.md titled 77EB5. This is the hash. These are unique IDs, so they're not meaningful except for referencing them in a technical sense. Again, all you really need here is the author, the reason, and the timestamp, but this will be your unique identifier. So can we see this? Yes or no from the team? Can I see the contents of the repository at that time? Can anybody? On the right panel, no. Yes, so it won't show the contents of the repository at that time. That's a good point. On the right panel, it's actually only showing the changes. So these are not the contents, but only the changes. Good question. So the answer is no. We cannot see the contents of the repository. There's a good suggestion here just to check out a commit. It's a good suggestion, but it's not something we can actually do. So let's go ahead and get the terminology straight and the approach straight so we can do exactly what I think is being conceptually suggested, which is setting the state of the working directory on the local machine to the state at the time of that commit. So commits cannot be directly accessed. Again, an essential element to think is that branches give us access to commits. So in fact, what we're going to do, it says you can check out the commit, don't do that. What we're almost always going to do it through creating a branch. So you can check it, but again, it's not the right thing. What we're going to do is create a new branch, something like go back, right? When we check out, and you can see again in the branch selector, we're checked out the go back branch locally, and it's pointed to the update readme.md commit. So if I go now to the working directory, the local files, I'll only see the contents of the working directory at that point in time. And you can see that that's correct. It does not contain a second file anymore. If I recheck out the main branch, the second file immediately comes back. So it is, again, giving you access to the exact snapshot of the working directory at the point in time when a commit was made. And you can do this indefinitely. You could have, if you wanted, you could have a branch pointing to every commit in your history. You don't need to do that because, as I said earlier, branches don't contain any information. If I check out the main branch, I can happily delete the go back branch. It's going to warn me because there are some times when you don't want to do that. But I haven't lost any information from my repository or my history. I can't get here anymore, but it's just as easy for me to go ahead and create a branch. And I can even just reuse the go back title because that was destroyed. And I'm back. So you can already see very quickly, even with just a linear history, how to get through time to various versions and access those previous materials. So is that making sense? Any issues with that? Good. Okay. So for now, I'm going to go ahead and check out the main master branch. I'm going to get rid of go back, and we're going to move forward with it. So we're going to start we're now going to contribute to this project as a team moving forward from the current version. So if you have this one open, what you're going to do now is create. So starting from where we are now, actually not starting from here, always check out the develop branch before doing anything in Git flow. So we're never working off the master, we're always working off the most recent version of develop. So please go ahead and check out the develop branch. You'll see that it is like that, and you'll see that nothing changes. This is a special commit here called a merge commit, which simply updates this material to be the same as that material. So there's no new work in it, and it's why it has this funny message, and it doesn't say a functional update. From here, we're going to create a new branch. So can we all see that? So create a branch here, and when you're going to name it, we're going to name our branches functionally, right? In accordance with those kind of mid-level tasks. So we're going to call this something very simple. I'm going to call it from my own branch. So we typically don't spend time working multiple people on the same branch. So I'm going to say BBD, like this is mine. And I'm going to say it's for a new file. So when we're writing branch names, we only use lowercase 26 English letters and dashes and occasionally underscores. But this is the naming convention for branches. Anything else will break, and this will work. So everyone can go ahead and do that for themselves on their computer at this time. You can call it new file, you can call it add file, because that's what you're going to be doing. You're going to be adding a new piece of material to this repository. So when you have it there, that's great. What you'll see is, and when Juan gets his thing sorted, he'll see this as well. He'll see that on this right-hand bar, there are two places. There's the local copy and there's the remote copy. So origin is the default name for the cloud storage on github.com. You can see that the origin only has 2 branches, whereas the local copy on my machine, it's got the little picture of the computer, has 3 branches, the same main master, the develop, and the BBD new file. What I'm going to do now is make this branch available to everyone by pushing it to origin, and it'll suggest a name for that branch on the remote repository. It's by default the same, and I'm going to submit that. Now, everybody else should be able to see the appearance of the BBD new file branch, not locally, but in the remote. It'll show up here as well as a branch that only has the little GitHub icon and not the little computer icon. So everyone should be able to see that now on their own machine. So GitHub, like I said, is doing this, transferring the information between us so that we can collaborate using the underlying software. So can people see that? Can anybody not see that?
How do you commit? I got it up to this point finally, but I'm just wondering, like I'm trying to create a new file, but
yep, that'll be the next step. That'll be the next step.
Oh, okay.
Yep. Amish, does this happen on its own? Do we have to pull? So you do not have to pull, but it's a good point. What you may have to do is fetch. So sometimes you need to right click and fetch the origin, which just says check for updates. It's not continuously checking, it checks on a like pretty regular schedule, so things should appear. But if ever something is behind, you can just fetch, and that'll tell you updates without changing anything. I think, is there a quicker way to do it? There probably is, but I don't know a shortcut key for it. You almost certainly can, and if you pull or push, it'll check or something. So you should be able to do that. So now what we're going to do is create do the same. So if everybody can do the exact same thing for me, which is go ahead and push your branch here push your branch to the remote repository so that everyone can see them, that would be wonderful. So again, you haven't changed any files, nothing else has been done. You're just letting the server know that, hey, I opened a branch here. Here's a flag. I want everyone else to know where this new access point is. And in fact, you can see it accesses the same commit as the develop branch. So as I said before, there's no sense in which commits are inside or belonging to branches. Although we will start to think in that term a little bit as we move forward. Strictly there's a couple of good ones, right? So people are starting to pop these in. And in order to get them on my local machine, all I have to do is check them out. they get added to the local material. Again, a branch doesn't have any information. All it is a reference to this unique identifier. So I'm going to go ahead and make sure I'm checked out. Now we're going to do some work. I'm going to make sure I'm checked out on my branch. So the branch selector says BBD new file because it's my branch and I know I'm going to work there. So make sure you're checked out on your own branch. And then we're going to do some work. So let's pop back over to the actual local machine. So in terms of work, nothing changes. We're going to do the same kind of work we did before. I'm going to open the repository working directory here in the Atom editor. You can use whichever text or code editor you want to create new files as it goes with your usual workflow. You may, you use any variety of things to edit files. So we're going to do the very typical approach here. I'm just going to create a new file. I'm going to, what did I say it was going to be? I was actually looking this up. I was going to be Parliament. So we're going to do song lyrics here. Parliament give up the funk. Actually, that should probably be an underscore. So naming conventions, whatever. So I'm going to create that new file. I actually need to rename it because it needs to have a file extension. I'm going to make it a .md file. So it's a, oh, come on. It's a markdown file, which is a standard text format, which is automatically readable through services like GitHub. They're mostly built around giving you access to these kind of files. It's a very nice plain text format for saving information. Is everyone able to do that? I would say do the same, pick a song that you like, and go ahead and create that file here in the working directory. So you can see it's added to the actual file list. So I'm now creating new information on the machine, not touching Git, right? I'm in the file system doing my normal workflow. So let me go find Safari and get the lyrics. Parliament give up the funk lyrics. Copy all that. I'll just go to the first verse or so because it's being a pain. I'm going to paste it in here just like everything else. Save that so it's updated in the file system. And now I have a file containing the lyrics to my song saved in the system. Does that make sense? Is everyone able to create a file containing some lyrics for your song? Any problems doing that?
Could you, hi Ben, could you just show once more where you started creating the new file from?
So again, that'll vary depending on your file system and your editor. In Atom, it's simply there's just a new file selector from the top level folder, which is the control. It knows it's a repository and it knows it's a folder, so it just lets me have file system actions. You can't do it here. I think Windows has a right-click new file, but I always just do it through Atom. The other thing you can do, of course, is copy and paste an existing file to get a new file and edit that one directly. Does that work? So once you've created a file containing some lyrics, just go ahead and stop me, anyone, if you're not ready to move forward. But until then, I'm just gonna go ahead. So once you've created a new file, and you'll see that actually Atom recognized that it's a new file, and because it's linked with Git, it gives me some more information. I'm gonna get this new visual in GitKraken. So it says, it knows that there are changes, and I can click on view the changes in the working directory, and it'll actually move me up to this spot. It says WIP, which is work in progress. So it means you have made changes to the underlying materials, but haven't stored them in Git. If you see DS store, that's a Mac thing. So I'm just going to delete that. So that I'm only adding the lyrics that I want to add. Now, nothing is saved in Git yet. So like we said at the beginning, you have to be it's a manual process to add these commits to the history of the project and repository. In order to do this, we have to do the things that we have to give it the information that it needs to continue the history. So we stage the changes. Most times you'll just click stage all changes. As you do more advanced work, you may do it. There may be other things that you want to do, but for now we click stage all changes. That means these are ready to be snapshotted in our history. And then we add the commit message, which is the why, the title, the reason of why we have made this commit. These are limited to just a few characters. And the syntax is the style for these is an imperative tense verb starting with a capital letter and a short description. So you can see something like merge, branch, develop, add a second file, update readme.md, almost as if it's a to-do list of things being checked off. So that's the style for writing these so that people know what you're doing. There shouldn't be stuff like stuff for blah, 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 or something unintelligible. Forward and clear because people may be looking through this history later. So I'm going to say add Parliament, give up the funk. So basically a properly sentence cased short brief saying what the task is for that commit. Then I'm going to commit those changes, and it's going to change from this work in progress type indicator to a full commit that is only accessible through my branch. Now, here's the only time when we start to think about commits as belonging to branches, right? What you'll see now is that no other commit has this work in its history. And because we know that branches are the things that give us access to commits, if I delete this branch, I will have no way to get here, which means I'll lose this information. Weirdly, it'll actually still exist in the history, but there will be no way to access this commit and it will get destroyed from the history. So this is the only time when we think about branches as being live or like having like containing commits is when it's the only way that we can access them. That is a special condition here where it's called a head commit, meaning it as you think about it as like a splitting vines or something. One part has a head that doesn't connect back into the broader network. So that can be lost. So I don't want to delete this branch at this point, but once it's no longer a head, we'll be able to do that. So the next thing I will do, so if everyone should do something like that, so that they add a new commit to the tree. Then you're going to push your changes, your new commits to the cloud storage so that everyone else can see and access the new version of the repository. So now the next time that you fetch origin or it updates automatically, you'll see this new commit appear and you'll see the BBD new file branch available to you. So if you can all go ahead and commit and push your branches to GitHub now, that will be fantastic. Just let me know if you've done it so I can fetch that and see some new branches. I don't know what that means. That is also a new one. I don't have an organization set up here. I've done it outside of any organization. Now I'm going to be going to Google that. Was anyone able to push material successfully? Juan or Avnish?
I mean, I think I did, but I'm not sure.
I don't see any changes yet from you. What is your branch called?
It's called JCNU file.
JC. I don't have a JC. Have you pushed it?
Yeah, I could try just right click push, right?
Yeah, just normal, an ordinary click, yeah.
Yeah, I just did it, but
Did you
interestingly, I see a lot of files from you from like 3 years ago and things like that, or a year ago. So like all of a sudden a bunch of files opened up here. Like, I don't know.
That's weird. You might have gotten a they shouldn't have been able to get a different version.
I see added big lecture data, delete temp.txt, added material, blah, blah, blah.
I don't think you're on the right repository.
Interesting. Okay.
Is it the Git flow demo? It should look exactly as I have it. There's no other materials out there. Unless you copied it just now, right? You didn't do it before the session?
Right, I just did it just now.
Okay. I mean, you can just copy and paste a file and then just edit it. Remember, GitKraken does not interact with the file system. It cannot create files. It cannot edit files. It is not a code editor, right? It is only for managing the repository history through through Git itself. So it's not for interacting with the files. That you just do the normal way. You know how to create a file. I know that. I don't know what the issue with the authentication is. Have you, for both people who have you may need to request GitKraken access, have you, if you go into the preferences, so if you go into preferences and then, sorry, this is being slow on that. You should be connected to GitHub. So you should have logged in. Usually this is resolved by logging into GitHub the first time and getting the success connection message. So if you haven't done that, you should be able to, yeah, you should also access that this way. So try, if you haven't, in the integrations tab, you should be able to connect to GitHub, and it should be a default option. It'll look, it should just give you that option. It'll look something like this. So then you should get this kind of connection if you haven't done it already. Were you able to do the trial exercise on your own? Did that work? For people who are having push fails? That's all right. I will do. And you're okay, and you were able to push and pull from. Yeah, so there must be just something with the authentication. Sometimes that happens. We'll get it sorted later. Well, as you're working. So let me just show you what we want to do, which is what I'm going to take. I'll just go ahead and create a couple of additional branches as if I'm working with other people. So I'll create BBD new 2. I'll create BBD 3 so I can show you how this will work when everything is hooked in and working properly. So I'll go ahead and do the exact same thing. I will create another file. We'll do Bohemian Rhapsody because everyone knows that. .md. I'm going to go for the lyrics. Can I get one more song suggestion in the chat? And put the links here. Very good. Everyone knows that one. Save it. Same thing. Add Queen Bohemian Rhapsody. Stage commit. So we have it now in a second branch. And you see, so this toggle here actually is usually hidden. Make that graph wider so you actually start seeing the different branches out well. And then let's get one new file. So I go back and check out BBD new 3. I'm going to go with no suggestions. People not here for music. Let's get some Elvis. Let's do Jailhouse Rock. I love that one. So same thing back here. Create new file. Elvis Jailhouse Rock. Save that. Do the change. Add Elvis Jailhouse Rock. Stage commit. So now we have 3, and I will now push 3 and 2. So now everyone can access all of these, right? So they should now be appearing on your local machine in just this way. You should see the access to be able to get to these various versions. And as you'll see, just like we did before, this is now no longer historical, chronological, but it's simultaneous, right? You can move between the versions. You can move between the version that has Parliament. You can move between the version that has Queen by actually clicking on it. There's one. So now we have a niche song push. What's the, yeah, great. And I can go ahead and check out, something got weird with that, but it's fine. So I can go ahead and check out Avnish's branch and see what he's added, which is, I don't know, he hasn't named the file. So what should this file be called, Avnish? It's not IDS song file. It's the name of the song.
Demons.
Demons by?
Yep. Imagine Dragons.
There you go. So I'll rename that and we'll call it Imagine Dragons Demons. So we've now renamed the file and we'll change the type so that it is also an MD file. That way keeping things in order. So you can see that now I can make some changes. Again, I have the ability to change it and I can say fix style for Imagine Dragons Demons, right? A short description of what I've done, stage it, commit it, and push it. And so now Avnish and everyone else also has access to that version of the repository, which contains Imagine Dragons. So you can now move between these simultaneous versions very easily, right? And see what people are working on. Does that make sense to everybody at this point? This is the second hardest part. We're almost there. Any questions about having multiple branches with different types of work going on in the same repository? So the last step is the problem that is gonna be pretty obvious to you, is that you want a version of the repository that has all of these songs at the same time, right? Because that's what collaboration is actually about, is doing things together and then having them in the same place. So we're gonna do that now. And what we're gonna do is through using GitHub to manage our collaboration on this project. So I'm going to go to GitHub, if I can find my browser window, and show you all how to do that. So I'm going to go to GitHub. It's going to automatically feed me some suggestions. I'm going to ignore them because I am not going to do that. We always try to do things here manually. So what we're going to do is open what's called a pull request. I think this is a terrible name for it. It should really be called a merge request. But what a pull request is going to do is combine versions of the history so that they create new commits that have more shared history. And you'll see what this means in just a second. So let me create a new pull request. I'm going to take the base as develop because we are always merging our work into develop. I'm going to take the new file I added here, which has Parliament give up the funk, create that pull request. And I'll be able to go on and see what's changed, what's been done before confirming that I want this on the develop branch. I do because I know it's good. So I, as the administrator, am going to merge it and confirm that merge. Then I can delete the branch because I know that that information is saved in a common history with develop. You can see this happening in real time here. As I fetch the origin, you can see that Parliament's give up the funk is now in the history for the branch called develop. I don't need the BBD new file branch because I now can access that information from another point in the graph. And if I check out develop, I have access to basically nothing new because that was a commit you've already seen. But if I add another one, for example, if I go on to here and I want to create another pull request, so I now want to add the Imagine Dragons song. So I go to develop. I'm going to compare it to the ADS branch, create that pull request. I can see what I'm going to be adding to the history, which is Amnisha's song, and then the cleanup I did on the naming and styling of it. I can always go and see exactly what these things are, and we can have a conversation about it. Or I can go ahead and merge it, which I'm going to do now. I can delete the ADS new file branch from the web. I can see now that there's another commit on develop that I can pull to update my local version. And now the version of develop I have has more things in its history. It has Parliament's give up the funk in its history, and it has Imagine Dragons Demons in its history. So what should I expect to see when I go and look at the working directory? I should expect to see both of them. And indeed I do. When I look at the directory, when I have checked out a branch pointing to a commit that has all of this work in its history, I see that work combined in the same place. And I can go ahead and do that for all of the materials that are open, which I'll do very quickly. I'll add Jailhouse Rock. And I'll merge it. And I'm going to keep my branches clean. And I'll add Bohemian Rhapsody. Oops, and I say I've made a mistake here. I've accidentally tried to commit it into master, so I'm not going to do that. I'm going to edit it and make the base to be develop. It's going to recheck that. Yep, Juan, thanks for having you. Everything will be available. Obviously, you have the access to the stuff online if you want to go figuring anything else out. So now we have a version of develop, which we can pull, which now has all of these files in its history. I can keep my branch lists clean because I know that I have access to these informations. And if I check out develop now, and go to the working directory, I can see that all the work from all of these different branches has now been merged into one version of the repository. Now, as we said, develop is still pretty messy because it has these executive level, these mid-level tasks, right? Adding Give Up the Funk, adding Jailhouse Rock, adding Bohemian Rhapsody. What I want to do now is create a clean version for our boss and say, hey, we've added the song catalog that we wanted. This is an even simpler operation. All we do is go back here and start a new pull request from develop into main or master. What we can see is that we're adding all of these historical components. Everything that was done in the repository that's now in the history of develop, that's not in the history of master. We can create that pull request. We can do various tasks updating to make sure that it's ready. And finally, I can merge that pull request. So this is why we work, and we don't delete to the developer, so we leave that as it is. So this is why we work finally with the Git flow style, is that once everything is done, we can move forward to a very clean history of the master branch in terms of actual changes and see how all the work was done to get us to that point. And I could also rename this. I could have renamed it in the pull request and called it something like finished song catalog. So yes, so merges I personally think should be managed on GitHub. You can do them locally, but it's generally better to handle the collaboration in the collaboration platform. So GitHub is really designed for that. It'll let you have some back and forth, between collaborators before doing something, and that's really a workflow that we do follow and recommend, and then pulling those back down to the local repository. So managing the collaboration through a platform that's designed for it is the way to do it. Yep, and you can do it locally, and some organizations have to will, but this is the way that we try to organize it. So that's really it. I mean, this is the collaboration workflow. This is GitHub, GitKraken to do that, and this is what a small project might look like with collaboration from a couple of contributors. So I am going to stop lecturing and demoing here and save the last 10 minutes for any, we ended in 10, right? I'll take that as a yes. And save the last 10 minutes for any questions or comments that you want to have. I can demo anything if you want to see it in a few minutes, and then I expect that the other sessions will be returning in here, like I said, within a few minutes as they wrap up. Yeah, otherwise, thank you all for joining, and I hope it's been useful. Yeah, Richard, go ahead. Can you unmute yourself, or yeah, go ahead.
Yeah, hi. So thank you so much for the demo. This is just this is not a question related to the steps as such. I just had a question from my team lead when I proposed introducing some version control methods in our workflow, and she was worried about us using restricted data and how all of those things factor into this in terms of security, or I think she was a bit concerned about even some of this data involves human subjects research. Are any of these things even relevant when we do this, or is there a way to reassure someone that it's secure?
So it is not secure. We do not store data using Git and GitHub. It is not an appropriate way to version control data or databases, and you should not be putting sensitive information in a system that is managed by GitHub. What we do is we store our sensitive data in an organization approved solution, which at Georgetown is the enterprise version of Box, and at the World Bank is an enterprise version of OneDrive. And those pass our security requirements for storing sensitive data. And then we, when we're working on code, right, code and outputs, those are stored in a Git managed repository, right? So there's never anything sensitive in our setup that gets exposed to Git or GitHub or is stored on the cloud. other organizations do it differently. You can set up an enterprise installation of something like GitLab, which will be internally hosted, not available outside, but that tends to be that's an expert level solution for people where the code and outputs themselves are sensitive. To a degree that's not even like you want them up there. I mean, we use private repositories to work on things using GitHub before releasing them to the public. But that's still, even if a repository is private on GitHub, it is not secure. Microsoft Corporation has access to your materials because you're using their services, unless you are hosting it yourself with the enterprise grade setup. So I hope does that answer some of the question?
It does. Thank you.
Mm-hmm. Yeah, so again, we keep it separate. If you have sensitive data, it does not touch this stuff, but it's very easy to, write a pointer to say, here's the code, go get the data from the protected location, do the processing, without ever resaving the data or putting anything else inside the connected location, right? So it's very easy to keep it separate. Yeah, that's a great question. And the same for outputs. Usually we'll then, because we don't, like I said, want to be updating, PowerPoints and PDFs and all this stuff on GitHub, there's no reason to. We have them print back out to Dropbox or OneDrive or Box. So the outputs, again, don't have to be done in here. It's very easy to write a file path that says this is where we want to print stuff to. Or say you're doing data processing and you want to save a new copy of the data set, which is still sensitive. You just say, oh, here's a file path, save it in the secure location. So that's how we handle, the inputs and outputs for code that's managed on Git when the inputs and outputs actually need to be held somewhere else. And we write that up in the code as we do it.
Okay, thank you so much.
Mm-hmm. All right, anything else for today from this group? I think, again, you've been great. I hope that this helps and gives a sense of what we're trying to do. I'm going to go ahead and kill my screen sharing now and give you guys 5 before is there something else after this, or where's the?
Hi, Ben. Thanks
Yeah.
for the talk. I just have a quick question about, because when I was doing my work, I tried to create folder structure. But it seems to me that the GitHub is not tracking the empty folders. So I'm wondering if you have better suggestions how that I manage that to keep it synced. Yeah.
So this is absolutely correct. That's a fantastic observation. No, GitHub does not track empty folders because, and the reason is, folders don't actually exist anywhere. They are not a traceable object. Only files exist, and folders are actually invented as an illustration by your computer by a special construction in the file name, which is the slash. So they're not real, which may come as a surprise to some of you. In order to have Git track them and GitHub track them, which is exactly what you want to do, we've actually written a software, not a software, but in Stata, we've written a Stata program that does exactly this. It's part of the Dime Analytics's IE toolkit package, and it's called IE Git Add MD. What it does is it creates a markdown README placeholder in every subdirectory so that they will be indexed by GitHub. So we have a solution to that. If you search for IE, and I'll put that in the chat, you should be able to find that through Googling it. I think we might have a wiki page for that, but it's a very simple utility that solves exactly the problem that you're saying, because that's usually the first thing that we want to do.
Yeah, that's super helpful. Thanks.
Yeah, absolutely. Do I need to turn anything else off here to be ready to end the session, or because I know we have the main room?
Yep, we have about 5 minutes remaining in this session. So if anyone has questions, feel free to ask. And then everyone will be joining us in this room.
Great. Is there another session, or?
Right, there is another lightning talk from Fernando.
Okay, awesome.
He's going to be talking about open policy analysis.
Great. Well, let me give everyone a 5-minute break then, and I will. I'm going to log off. I have to do other things.
Okay.
And Fernando's talk is excellent, so you should all look forward to it. And yeah, thank